Hello students, in our last module, we have discussed about the basic part of electric circuit, which were a cell, a switch, and a bulb. Now during science practical activities, we have to draw such circuits many times, and it is quite difficult to draw circuits showing actual shapes of the components used in the circuit. Thus, to solve this problem, we have to look for a simple way to make our work easier, and here comes the need of symbols of electric components. Therefore, we use symbols of electric components to draw circuit diagrams. So, how do we represent these electric components through symbols? Well, let's start with the electric cell first. So, in our previous class modules, we all have studied that electric cell has a positive and a negative terminal. And how do these terminals are represented in symbolic form? Well, positive terminal is represented by longer line, while the negative terminal is represented by thicker and shorter line drawn parallel to the longer line. And the metallic wire, which connects the different electric components, is shown by straight lines. Next is bulb, which is represented by this simple symbol, a single turned coil inside a circle. Symbol of switch in on and off is represented by two dots and a line. So, when it is in on position, the line touches both the dots and it forms the closed circuit, thus allowing the electric current to flow. While when the switch is in off position, the line touches only one dot and it forms the open circuit, which restricts the flow of electric current because the path is broken or incomplete. Thus, an open circuit does not allow the electrical current to flow. So, this is how different electric components such as cell, bulb, and switch are represented in an electric circuit. And when a closed and continuous circuit is formed, then current starts flowing in the circuit from positive terminal to the negative terminal of the cell. Now, we have studied that electric current is due to the flow of negatively charged free electrons. And flow of free electrons in a closed circuit is always from negative terminal to positive terminal. While electric current flows from positive terminal to negative terminal of cell, so direction of flow of current is always opposite of the direction of flow of electrons. Now you might be thinking that when current is the flow of electric charges, which is nothing but the negatively charged electrons, then why their direction of flow is taken as opposite to the direction of flow of electric current? Do you know the reason behind this? Well, it is so because the direction of an electric current is by convention the direction in which a positive charge moves. And the conventional current in the electric circuit flows from the positive terminal to the negative terminal of the cell. So knowing that the actual charge carriers in wires are negatively charged electrons, it makes this convention look a bit odd and outdated, but this convention is used worldwide. Now let's come back to our module. So, this way of representation of an electric circuit using symbols is far better and simple than drawing the circuit with actual shapes of the components involved. And if you practice more and more, then you will get to know that how easy it is. And as we know that a cell is represented by a longer line and a thicker, shorter line parallel to the longer line, and if we connect two or more cells together in such a way that a negative terminal of one cell is connected to the positive terminal of the next cell, then what do we call this combination of cells? Well, such a combination of two or more cells is called a battery. And more about this battery will be discussed in our next module. So, this is all about symbols of electric components, and we will meet again with yet another interesting topic of electric current.